I'm going to share the screen. We're going to begin to introduce generics in chapter 19 today. So what is generics? Generics is to parameterize data types. So when you write a method, you pass the arguments, and the arguments are defined as parameters in the methods. So in the methods, you can parameterize the arguments. So these are called parameters. And the data type. So every variable and every parameter, you have a data type. And we can also parameterize the data type. So here's the data type. It's a string, it's a date. So you can have a generic type. So that is the generics this is for. This is in chapter 19. We're going to talk about this, generics. So let's first look at this example we already have actually from the array list. When we study array list, we already use the generics. So the array list. So this is the array list. So we look at the array list. This is the array list, and this is the generic type. So that means you're going to take any concrete type to replace this E. E is so representing a generic type. And you can call this E and call this as X, Y, Z, any of this just by convention. So we use E a lot in Java. So this is E is a type. So this is the generic type. All right, so this is the, when you create a list, so here, and we have this is list. What is this list? It's array of string. So now you can see that here is E. Now we have this is string. So that's the generic type. It is replaced with a concrete type when you actually use it in your code. All right, so this is the to define it. This is UML diagram. You're going to see this is the UML diagram. But you see these two tabs here, and this is the since Java 5, and this is the before Java 5. So before Java 5, and we actually also have this class. It's array list. It is like this. And since Java 5, it is improved with this generics. Well, now what's the improvement here? So what's the benefit of using generics? And the benefit of using generics is you make your program more robust and easy to find the bugs. And so you're not going to have runtime errors. And so this is something is we're going to have to look at the example to show this. All right, I'm here. Look at this example. So look, this is the string right here, the list. So you're going to add this string into the list. No problem. All right, what happens you add something other than string? So this is the integer. Add this integer to the list. So that is not right. And we have this list. It's a list of strings. So you only can have strings. And so now with this integer, it is going to have an error. So this error, when you write a code like this, it's going to be detected by the compiler. Compiler can see, hey, it doesn't match the definition for this list. It doesn't match. So this is the error is detected at a compile time. All right, so now if you use this array list before Java 5, and this is going to be different. I'm going to show you something with another example here. You're going to see this is here. There's another example we already know is the comparable interface in the Java API. So this is the comparable interface in the Java API. And with a generic type, this is just called as T, just by convention. So we have this is a E or T. So T is a lot of time. And so this is like in interface, we have this is the data type, this is called T. But it doesn't matter, you can call T, E, X, Y, Z. All right, so this is T. It's a generic type. So here you're going to compare this object here with another object whose type is T. So it has to be TT. So the two objects you're going to compare and they have the same type. So this is the comparable interface. So prior to Java 5, and this is how it's defined in the Java API. So this is defined in Java API. The comparable interface is defined in the package of java.len. Okay, now, this is before Java 5. This is after Java 5. All right, so now we're going to see the benefits of using this generics. Using this generics, when you write the code, so here is after Java 5, including Java 5, starting from Java 5. So you write this, it's comparable. There's a lot of classes in the Java API implements the comparable interface. So like a date, string. So there are subtypes of the comparable interface. So here we create a new date. We're going to assign this into the reference. It's a C. What is C? It's comparable date. So when you compare this here C with another object, this object must be date. If it's not date, you're going to see a problem. It's going to have a compile error. So the compiler can detect the error in this code here. So the error is detected before you even run the code. So this is make your code robust. It's not going to happen when you run it, and that's not good way for the end user. So you run it, you get an error. No. So when you compile it, and so you know it's not correct, and then you can fix it, and before you deliver your product to the user. So now let's before Java 5, if you write this code here, so this is, we're going to assign new date and C. So what is C? It's just comparable. It doesn't say it's what specific type is. But when you do compare to, so you have to compare things that are compared. It's comparable. They can be compared. So here is a C dot compared to with a string. So it's a date, and here is a string that cannot be compared. Then you cannot compare so apple with orange. So they're not the same thing. It's just not right. But this is, you know, it's incorrect. It's something happened when you write the code. You made a mistake, but the compiler cannot detect the error in this. So we're going to improve it and make it very specific and using the generics. And we have this says this is the one specifically it's date. So here we're going to compare C with a string that's not right. So the compiler can detect this error. So the benefits of the generics is to improve the software quality and also for some simplifications of the coding. And you're going to see it later on. All right, so now we're going to go and so this is all the motivation here and the benefits, and this. Okay, by the way, I'm gonna check the due dates here. There's a due date for this. It's September 1st. Okay, so this is the everything in this chapter 19 are due September 1st. All right, so now we're going to define our own generic classes and interfaces. So we're going to use this example here. So here's the example. We have a stack. So this time we call this a generic stack. So the generic type is E, and the stack, we know the stack. We've been using the stack. We know the concept. So here we're going to have this a class to model all the stacks. So the stacks we're going to have, we create stack 1, stack 2, stack 3. So they are all the stack. So stack 1 may be holding integers, stack 2 may hold the strings, and stack 3 may hold the dates. So you see all this. So this is a generic type, is E. Anything. All right. So internally, how do you store all your data in the stack? We're going to use a list. Very simple. This list is a java.ut.array list, and that's here is E. So it's generic E. Constructor, generic stack. So this creates an empty stack. So this is to return the size, the number of elements in the stack. And here's a peak. This returns the top element from the stack. So on top of the stack. And this is pop is to remove that and return the removed element. So here is this. Okay. Pop. And push is to add a new element into the stack. You push it. So push is empty. A stack is empty. So those are the methods here for this generic stack. All right, we're going to write the code for this. So here's the code. It's a public class generic stack. So this is E right here. And here is the private data field and the list. So here is, I'm going to create this empty list. It's a new java.util.array list. Okay, now, and please look at this. You could say this E, that's fine, but this is unnecessary. I'm going to use this, the brackets here without anything. This is because this is going to automatically detect it by the compiler. Say, hey, you're going to create this E, so it's already here. This has to be E. So it can be omitted. All right, so this is get size, here's a peak, see how you do this. And so how do you push? So how do you write the code for this push? You're going to push it. Okay, how do you do it? So here is the list. Look at the list. So what's going to be the top? So this is listed. You look at this, my gesture here. List, you look at, it can be horizontally on top right here. So a list, you can move it around this vertically and horizontally. So here at the end, you're going to add this. So here's list dot, you're going to add here into, this is O into the list. Okay, what about the size? What size is automatically? When you do this is list the size. Here is get size, list that size. Here's list when you add it, so it's there. It's, you don't have to do anything. It's list. The size is automatically reflected in the list. So when you do a pop, so pop, you're going to remove it. Remove the last one. So it's get size -1. That's the index, the last one. But you need to retain this because you're going to return it. So here's always list that get the last one. So here is return O. All right, how do you get is empty? How do you know it's empty? Okay, let's just return true or false. Okay, and for this the size, it's list dot get size. If it's equal to 0, then that's true, it's empty. So here we're going to overwrite toString and to get everything from the list and using list.toString. See how simple it's implemented. It is, this is the code and this is your design, and from your design and to coding, it's this. And you have now this generic stack. It's actually a data structure holding the elements in the stack. So let's write a test code. So we have a stack 1 is all the strings, and we're going to push the strings into the stack. All right, let's write another example. This time we're going to have integers. All right, please note that. So you cannot use the primitive data type int. You have to have an object type. So cannot have just int. You have to say integer. This is the object. All right, so this is for stack 2. When you push it, you can write this 1. This is going to be automatically, 1 is automatically converted into object for the integer. It's using the wrapper class integer. So this is called auto boxing, and that's easy. And so this is convenient. You don't have to write a code to do the conversion to represent an object for 1. All right, so let's move on to the next. We'll write generic methods. So let's look at this here. We're going to write this code here. It is the, look at this integer. Okay, and this is the integer. And so there's the array of integer objects and array of strings. So all these objects, string objects. So here, we're going to print all the integers, print all the strings. I'm going to write this code here. It's print, this is E. It's a generic type. I'm going to print this E. It's a generic type. Here's E. All right, so what I'm going to do is I'm going to use this. The syntax is E is right here. So here is a generic method. This E is a generic type. So it's not going to work if you don't have this part. It's going to be incorrect. So you have to put the E right here. So this is the syntax for this generic method. When you have a generic method, it always has to be this static level, because if it's not, if it's like the previous one, we have the generic stack, that E is the class level. And so here is the method level, it's right here. So when you use it, so what is this E? E is integer. See here is, this is the generic method demo. So that's the class here, generic method demo dot. So what is this E now I'm going to use for integer? So here is for the array of integers. And this is for array of strings. All right, so now next, we're going to have, we can have bounded some restriction on the generic type. So this is called a bounded type. So here's the bounded type is this. I'm going to have this, the geometric objects. So here is rectangle, and this is a circle. And I might want to see if they have the same area. So it's rectangle and it's a circle. Do they have the same area? So here's the method is it's equal area. It returns, this is Boolean true or false. So this is E. All right, so now if you just write this, it's not going to be right. Okay, because this is any type. There's no get area defined in this E. It's only you have to say it is extends geometric object. It is in the geometric object we can use this get area. These are defined. So we know back in chapter 13 when we introduce inheritance. So we have and this generic this is the a geometric object defined there. That's actually abstract class, geometric object. Rectangle is a subtype of geometric object. Circle is a subtype of geometric object. So now here is get, it's fine. So you can say, hey, object 1 dot get area equals to object 2. So that's all fine, because now the compiler knows that, oh, what's E? E is a subtype of geometric object. So E has this get area method. All right, so this is called bonded type. So this is the bonded type. You can have this E, it's restricted, and it's a subtype. It's bonded to geometric object. All right, so please study this case study and to write the code and for this sorting array of objects and using the generic type here. So please write this code and see how this works. Okay. All right, so I'm going to move to the next. Okay. So we're going to look at raw types and backward compatibilities. All right, so what is this raw type? And the raw type is this for backward compatibility. It is this. So we define the generic stack class. So the way we use it, we specifically say, hey, this is generic stack for string and for integer and for date. But now you're not saying anything here. Well, if you don't do it, this is still okay. And this is called the raw type. So the reason this is okay is for backward compatibility. It's because before Java 5, you can do it. Now, since Java 5, you should still be able to do it for backward compatibility. Otherwise, all your code is now not going to work in the new Java. So that's here, it's for backward compatibility. It's not good. We're not going to use it when we write the code. We don't use raw type. You're going to get a warning if you compile it. But because for backward compatibility, it is still allowed in the Java code. All right, so that's called raw type. So you get a warning when you do it. So in the using this raw type. So I'm gonna move on to the next. Okay. This has been true for Java. Is any code you write from day one when Java was invented, it still works now today in the new Java. It's a very good selling point for Java. It's really backward compatibility. Some other languages, when they change, and it's broken. So things you've done in the past, it's not working anymore, and that's usually not good. And
I have a question.
Yeah.
You mentioned the backward compatibility in Java. Java's been around for a really long time, so I would wonder, is the backward compatibility with regard to the syntax, language features like generics, or is it just, or does it include like the libraries as well?
Libraries as well, anything.
Okay, that's interesting. I
Anything.
didn't know that.
Okay. All right, so next we're gonna look at this, the wildcard generic types. All right, so this is merely some syntax, a very useful syntax. I'm going to look at the first thing is, why do we need this so-called wildcard? Let's look at this example first before we see the need. So this is the example. We have this generic stack. So here is integer. All right, so this is the new generic stack. And so we're going to push integer and this 1 to -1. All right, so now we're going to do this is to get the maximum of this from the int stack. And this is the method max. So here we have this max, and this is a generic stack. So here I'm going to use the number, but it's not going to work because integer is a subtype of number, but generic integer is not a subtype of generic stack. This is not going to work. This has to be some way to do it. So the way we do it, so if you run the code, you're going to see there's an error here. So there's an error here. So you got to do something here is to introduce this new syntax is so the you have to use a wildcard. Use this, anything that extends number. So using the question mark. So the question mark, this is called a wildcard. So this is the wildcard symbol, so it's question mark. Extends, so anything extends number. So that will cover this. Integer, yes, matches this. Is anything that extends number. So the integer extends number. So this will work. All right, so here we have this. If you have just question mark, and this is called unbounded wildcard. If you have question mark, it extends something like object. And so this is called a bounded wildcard. And there's another one, it's called a super wildcard. If you have something, it's a question mark, a super T. So that is the, it's called the low bound wildcard. It's a super bound wildcard. So here's some example. I'm going to give you another example here. Is this one right here? Is this this one here? So we have generic stack. We have these numbers. Okay, we're going to do this print. So print what you need for this type. So what is the stack here? Stack is going to be, has to be generic stack. Okay, so what is the type? Okay, you can say it's anything. So here's a question mark. So that's just any type. So this is called any type. All right, the example here. We have this two stacks. This is the string. Stack 1. This is object. Stack 2. I am going to push string into stack 2, that's fine because it's the object, so you can have a string. And push 2 into this, that's fine. It's converted into integer object, so 2, this is fine. And this is 1, it's a string. Okay, now we're going to do add stack 1, stack 2. So this is add everything in stack 1 into stack 2. So everything in stack 1 into stack 2. This is add everything in stack 1 into stack 2. All right, so what is this type? Should be anything in stack 1 and stack 2. So this should be this here. It's a generic stack. And so this has to be a super type of T. Okay. So you cannot have just T. It's not going to work if you just say this is T. So if you run the code, and so it's not going to work. So let's say you compile and run, and you're going to get an error. Okay. It's you look at the error message, you can see that's just the reason is this. They're not. This is not right. It's just not match here. This string and this is not a string. So it has to be the same string. No, it has to be anything super of this string. So now if you compile and run, it's going to be fine. Okay. Okay. Actually, there's another way to write this is involving the whole thing. Think about it. We can rewrite it. Just not using this question mark super T. I'm going to do this. I'm going to fix this one here, T. This is T. But right here, I'm going to change this to what? To anything.
Extends.
Yeah, extends. So that'll work too. So it's going to be, yeah, subtype of this. So you're going to run this, should be the same.
One question. Does Java, I mean, they support generic arguments, obviously, but like, do they support multiple of them? So if you wanted to have a type that has T and S, okay.
Yes, T1, T2, T3, yes.
Yep.
Yeah, okay. Okay, I'm going to continue, have more, but I think I'm going to stop here. We're going to have the next class to finish chapter 19. So now I'm going to answer your questions for the program exercises from the book. Any questions?
Yes, I have one again.
Yeah.
So I specifically, can you still hear me? I'm just pulling it up. So specifically, the one that I had a question about was the 18.4 question 4. It's the programming quiz.
Okay. So I'm going to go back. I'm going to look at this 18.4. Which one?
Question 4, please.
Okay. All right, so this is 18.4, question 4.
Yes.
Okay. I'm going to write a recursive string return method revokes that accepts a string. Okay. And returns a new string consisting of the original string in reverse. Okay. All right. And the name of this method is called reverse. So we're going to have public. We're going to static and it's going to return a string. Let's reverse string s. Okay. All right, so we're going to look at this, return a string, and the method name, and so this is accepts the string. All right. Okay. All right, so this is, for example, if this is goodbye, so this is the reverse. Okay. And so here, some hint, reversing a string involves nothing if the string is empty and or has one character. Okay, so here, if, okay, I'm gonna just write this way here. If this s that the length is less than or equal to 1. So this, you're gonna just return s. Okay. So reversing a single does not change this, just to return s. Okay. Else, otherwise, concatenate the last character with the result of reversing the string consisting of first through the next to last. Okay. All right. So you're going to do this, you're going to return the last one, s dot character at. So what is the last one? Is this s dot length minus 1. So this is the last one. Concatenate the last one with. So the rest, you're going to reverse, do the same thing. S dot. Okay. All right. So this one here is going to be S. Okay. I think this is the S dot substring 1. I think the substring has two overloaded versions, and this version means starting from this index 1 to all the way to the end. Okay. So you don't have to write this way here. Don't have to write this. So, don't have to write here s dot. I'm sorry, substring 1. S dot length. You don't have to write this. This is okay, but I think this is the one. I'm going to give it a try. So. Okay,
Wouldn't you want to return or do the recursive call on everything but the last character for the string?
Yeah, because aren't we, like, it looks like we're excluding the first index there. I don't know, like, if that's, what we want.
This one here, it's this string, you're gonna return that. All right, let's look at this here. So okay, I'm returning something. It was okay. Yeah, it looks like here I'm returning CCC, so something here is interesting here.
The way you have the recursive call set up is you're returning everything except the first character in the string, which we need the first character for the last iteration. And with
First
the
character.
substring returning,
Oh, okay, yeah, I'm
Yeah.
going wrong. Sorry. Oh, yeah, this is actually 0. Yeah, sorry. Yes.
Okay,
Alright.
yeah, that's what I thought.
Okay, good. Got it. Thank you. This is going to be 2. Yes. Okay. All right. So this is with the yeah. So so this is the this is going to be the last one, and so we're going to need to get all the substring except the last one. So I got it right now. Okay. So now let's give it a try. Thank you. Yeah. Okay. So now still not right. Here is A, B, C, D, E, F, G. So
Why
this,
are you doing -2 and not -1? Or -2, I mean, not -1.
oh yeah, you're right. So I missed that one. Yes, thank you. That's right. Yeah. Yeah. So that's one. Yeah. Yeah. Thank you. So this is
Thank
the
you.
yeah. Thanks. Yeah. So that's a substring is so this is starting from this index, and here it's ending. The one is the one before. So you have to actually in order to get this is the the one you want to get is start length -2, but you have to pass this with this one more. Okay, good. Thank you. Thank you. All right, good. All right, anything else? Okay, so if you don't have any questions, feel free to leave. And so if you want to talk to me individually, so stay. Okay, bye.
Thank you.
Professor, I have one question.
Yes.
What
All
would
right,
be?
just a second. It's recorded, is okay?
Oh yeah, it's fine. Yeah.
Okay, yeah, go ahead.
In this classroom, will we be using any IDEs or just using the software?
Oh yeah, we have the IDs. So it's this is the if you need to test your code, you have to run your code and use IDE. IDE
Okay.
will give you really the best way. And
Yeah,
provide the code.
because I've been using Eclipse sometimes for helping with my assignments. So that's just a
Yes.
me thing.
Please, yeah, because you can also debug your code. That's
Right. All right.
Yeah.
Okay. Have a good one.
Okay.
Have a good day.
All right, thank you. Bye. Okay, if you don't have anything, I'm going to end this